Hi everyone, I'm going to be doing question one of week 2A homework. So, um, in this question, we are gonna try to find the electric current in a wire. So the cylinder represents our wire here, and these you could think of like the entire wire as like maybe like a highway, and like these electrons are just like cars zooming past, and we're standing at this checkpoint over here. So counting how many pass by in approximately 0.4 seconds. 0.4 seconds. So before we do any math, we could look at what we know, like our variables. So we have n, which represents our total count of electrons. So n is um a very big number, which is 1.9 times 10 to the 19th. And we also have t, our time, which I said over here is 4 oh, I wrote it wrong, 4.0 seconds, not 0.4 seconds. Um, t is equal to 4.0 seconds, our time. And then we also have E, which is the elementary charge. So like this is a constant. It's just like the amount of electric charge packed in a single electron. So it would be 1.6 times 10 to the negative 19th coulombs. So the problem asks for the current in I, which so what's a current? Like the current is just the rate of the charge flow. So in plain English, it would just be like how many coulombs of charge pass our checkpoint per second. So the formula for that is I equals Q over T. But if we look at our variables, we do not have Q yet, which is the total charge. So we only have the number of electrons. So to find the total charge, we need to multiply the number of electrons by the charge of just one electron. So that would be Q equals N times E, because of that's our variables what we have. And so if we plug that in, that would give us Q is equal to, what is it? N is 1.9 times 10 to the 19th. So 1.9 times 10 to the 19th times our E, which is 1.6 times 10 to the negative 19th. And the positive 19 and negative 19 exponents completely cancel each other out. So that will just leave us to do 1.9 times 1.6. So if we do Q equals 1.9 times 1.6 in our calculator, that would give us exactly 3.04 coulombs. So that will be our total package of charge moving through the wire. And so now that we have Q, we can finally find our current, which is I. So we could plug that in. I equals 3.04, as we found, coulombs. over our time, which is 4.0 seconds. And if you divide 3.04 by 4.0 seconds, you would get approximately 0.76 amps or A. So I is equal to 0.76A,